Hi, and welcome to this new section on image generation with neural networks. So, in this section, we are going to talk about neural network architectures which will help us generate new images. So, these types of architectures are classified into three major categories. First of all, we have autoregressor models. So in autoregressors, we have pixel RNN and pixel CNN. So these are two types of autoregressor models. Then we have another category known as autoencoder. So in autoencoder, we have standard autoencoder and then we have variational autoencoder. And in third type of category, we have generative adversarial networks or GANs. And in generative adversarial networks, we have a lot of different types of architectures, and there is still research going on to find new and more efficient architectures for image generation. So first of all, we have vanilla GANs, which were the first GANs. Then we have DC GANs, which is deep convolutional generative adversarial networks. Then we have cycle GAN, style GAN, WGAN, etc. So in this course, we are going to discuss these bottom two types of categories, which is autoencoder and generative adversarial networks. We will begin our discussion with standard autoencoders, then we will move towards variational autoencoders. We'll discuss the basic concepts of GANs, then what are deep convolutional GANs, the cycles GANs, W GANs, I GANs, style GANs. So there are a lot of GANs which we are going to cover in this course. This is a comparison table of autoregressor, autoencoder, and GANs. They have pros and cons. So autoregressors are very good at capturing dependencies, because if you remember, in autoregressor we have pixel RNN. So RNN models are very good at capturing dependencies, so that's why autoregressor are good at it as well. But the problem with RNNs is that it's slow and computationally intensive, and that's why we got CNN, but its performance is not very good. Then we have autoencoders. So autoencoders produce diverse image. The latent space is smooth, although the standard autoencoder latent space isn't that smooth. It's variational autoencoder that's latent space is smooth, and we will discuss these things in detail in the upcoming videos. But the problem with autoencoder is that the image quality is very lower. So we need to improve our image quality, and that's why we have GANs. So GANs produce high quality images, and their applications are versatile. You can use them to generate images from text. You can use them to generate images from random samples, or even you can use them for style transfer or image translations, etc. But the problem with GANs is that training is very unstable, and it requires high resources, high computational resources. You need GPUs, very powerful GPUs, in order to train a very better GAN. And when it comes to training instability, there's very common problem with GANs, and that is mode collapse, and we are going to talk about mode collapse in the GAN section, so don't worry. But these are some pros and cons of these three categories. And in the next video, we are going to start our discussion with autoencoders, and I'll see you there. Bye bye.